On behalf of the Alliance for Automotive Innovation and our member companies, welcome to this edition of Autos 2050's Future Driven Forum, our ongoing digital discussion series. Today's focus, Charging Forward, Accelerating the Electric Vehicle Market in the U.S. Please welcome our host, John Bozzella, the President and CEO of the Alliance for Automotive Innovation.
Good afternoon, and thank you for joining us today. The auto industry is in the midst of an extraordinary transformation. Automated and connected technologies and services are making personal transportation safer, more accessible, and more convenient. And the shift to electric drive vehicles sets the stage for a transition toward a net zero carbon transportation future. Today, we'll focus on the industry's EV transformation. I've witnessed a lot during my automotive career, but the EV transformation is different. This is revolutionary. This change is about a greener way to move, but it is also about our economic and competitive future. Who develops and builds the cars of the future and who sets the global rules of the road. It is about mining for rare earth minerals and reimagining our manufacturing plants and supply chains. It's about power generation and grid resiliency, and about access to charging, and even how we build homes and offices. In other words, it's bigger than any one company, industry, or government policy. For perspective, forecasters say that between 2018 and 2023, the auto industry will have spent $250 billion on electrification efforts. That's $250 billion in advancements, including plug-in hybrid electric vehicles, battery electric vehicles, and fuel cell electric vehicles. IHS Markit predicts there will be 130 EV models in the US by 2026. That's just 5 years from now. And yet last year's sales figures tell an important story. Despite growing consumer interest and the more than 50 EV models on the market, EVs make up just 2% of all vehicles sold. So that's roughly 300,000 of 14.5 million new vehicles Americans purchased last year. Today, we'll explore what is driving the shift to EVs and what it will take to accelerate the EV market in the US. And we will look at the implications for consumers as well as for our nation's competitiveness and economic security. Now, I'd like to introduce our panelists. Selena Mikawajek is the Vice President of Battery Technology for Panasonic. She joined the company after previously serving in senior positions at Uber and Tesla, and she brings to us a wealth of experience with new technologies and business models as we enter the electrified era. Swati Daji is the Senior Vice President of Consumer Solutions and Strategies for Duke Energy. She has decades of experience with Duke and its predecessor companies in roles across the business units, from procurement to chief risk officer. Duke has joined with 5 other utilities to push for more consumer vehicle charging stations, and she plays a key role in bringing those plans to fruition. And Dustin Krause is Director of E-Mobility at Volkswagen Group of America. He has spent more than a dozen years working on electric vehicles, first with Tesla and now with VW. He recently completed a cross-country trip in the Volkswagen ID.4 electric vehicle and is a key member of the team bringing that product to market in the US. I'd like to welcome all of you. So I just talked about some of the signs of momentum. Tremendous amount of investment across the value chain with traditional auto manufacturers, new entrants to the space, battery manufacturers. What's driving this momentum, Dustin? What's creating this move to investment in bringing these vehicles to market?
I think there's a couple things. One of them being consumer demand, of course. I think consumers are demanding more electric vehicles. We've seen the success of companies like Tesla really come into the market and creating a new market around electric vehicles. And there's a ton of excitement there. So I think anyone that's in an auto manufacturer right now wants to get in on that and figure out exactly how to do it. The other thing is, I think there's responsibility in terms of what we want to do in terms of sustainability. I think auto manufacturers globally as well as responsibility that is put on us from requirements from different governments across the world. So I think it's a push in about every single direction that you could have, where we're about to be at really a tipping point in all those areas. Consumer adoption, consumers want EVs. Two, we have goals in terms of sustainability, and we've got we have the responsibility to those goals. And the third thing is you've got governments around the world that are pushing for these technologies to really become the mainstay, and for all the right reasons. So I think certainly those three things are pushing us to that.
So Selena, Panasonic has been around a long time and a huge company that does a whole number of different things. So now batteries, but not really just now. So what's driving the momentum from the battery producer's perspective?
Well, okay, so Panasonic's been in the business of making batteries of one chemistry or another for like 100 years. It was one of the early business areas of Panasonic. And Panasonic's really made cells of every chemistry, from, some of the early alkaline stuff to NiCads to nickel metal hydride, and then entered the lithium ion market when it started. And Panasonic, of course, initially, early on agreed to work with Tesla and use lithium ion cells in EVs. That decision was really, it was high risk. It was not an obvious decision. It was actually a lot of faith in a future technology. And what I think leadership at Panasonic saw was really a technology that gets much better. And that's really what electric vehicles have become with the advent of Tesla. Before that, they were kind of considered glorified golf carts, and then suddenly Tesla came out, and it was a car that performs so amazingly. You put 5 people in a Model S and you take off like in a sports car. It drives a lot of customer excitement, and there's a lot of convenience with it, and people have really enjoyed the electric car. So for us, we can't make cells fast enough.
And Swati, so from the utilities perspective, you sell electrons. So do you feel momentum on your side of the business as we see more EVs coming into the market?
No, certainly, just like my co-panelist said, utilities too see this advent of EV penetration coming, and we are at that inflection point. But for utilities in general, this is not something new. Utilities know how to plan for needs. We planned for, kitchen been electrified after World War II. We planned for, air conditioning in 70s. We planned for computer and all the electronics in 80s and 90s. So we have been watching it, and this has been part of our planning process. And look, utilities know how to do this and do this well. And so it's part of our plan even today. And resiliency and reliability is another factor. So we just don't plan for it. We plan for it to make sure that it's resilient and reliable supply, because electricity is the new fuel for electric vehicles. So we take that very seriously, and we are moving our systems and our processes anywhere from generation to grid investments. Because I think you have to understand, as Dustin said, this is a little bit of sustainability and clean energy future that people are going after. So we are committed to providing clean electricity. That way we can be a good part of the clean transportation electrification advent. So I think we are prepared, and we are really looking forward to, as this progresses, to play our role.
Yeah, that's a really good point. And we can come back to that in a bit. But the idea that the electric vehicle itself on board is not producing any emissions, but of course, production of electricity does. And so the cleaner the grid gets, the cleaner the transportation system gets, right? So it's a system dynamic that you're speaking about. So we're seeing more models, we're seeing investment. There's, I hear Selena say, look, we're going fast, and yet we're at 2% of the market right now, the new vehicle market in the United States. Is that, how should we think about that? Is it early days and, we're ramping up? Is there potentially a disconnect between where you are as innovators and developers and maybe where the customer is at this point with regard to awareness? How do we square this momentum with what the market looks like today? Dustin, I'll start with you.
Yeah, it's a great question. And, I think, for Selena that's on the phone too, I think so one of the things that's going to help that is bringing down the cost of cells and making that more readily available. We need cars that are less expensive and more readily available for as many consumers as possible. We've got, a sales, VW group sells over 10 million cars a year. And when you think about those are new vehicles, and we're just part of the overall automotive industry. You look at Toyota, you look at some of the other large players, there's millions and millions and millions of cars being pumped into the market every year. The good news is that you can certainly feel this change happening, but I think there's going to be, it's going to be a transitionary period and probably won't be quite as quick as some other technologies because of the price points of cars and everything else. And then also, we only have so many cells. I think we're using about as many as we can produce right now, and we're producing all the cars. So the good news is that the demand is there. We're going to need to continue to grow the demand. I think there's going to be infrastructure that will have to come into place too. We already see it with Tesla and even the VWs that are going on the market for those fast charging stations that are out there, having to grow those stations all the time to keep up with the amount of vehicles that are on the road. So the good news is that we're headed in the right direction. I think customer sentiment is going that way too, but it's going to be a long-term initiative. I think about when I was at Tesla in 2009 and we were building cars basically in a garage at 12 or 15 cars a week, to now seeing Tesla last quarter deliver 187,000 cars globally. That's a pretty amazing thing that can happen in 10 years. Well, now it's like 12 years, but to see that now what the next 10 years will bring, I think is really going to be the telling. That's where all of the volume for electric cars is really going to start to come into play. And I think they're going to become more normalized with the consumer. So the next 10 years, I think to expect to be very exciting. I think we're going to go through some challenges too, particularly with infrastructure, with cells and making sure that we have enough to produce with EVs, but we're well on our way. I'm particularly excited. I think this is the most exciting industry to be in anywhere right now. So
great.
Yeah.
I want to talk about both of those things and drill into them both a little bit that you mentioned, Dustin, the cells, the development of the batteries, as well as the development of the infrastructure. So let's pick up on the cells. So Selena, what's happening at Panasonic right now? And the battery component, give our viewers some insight here. This is a pretty substantial portion of the overall cost of the car. And so where are we in terms of cost and development, and where are we going?
Sure. As was mentioned, cells are a limiting factor for most people. I mean, we're producing as fast as we can, and if we could double cell production tomorrow, we could sell all of them. But when we look at trying to double cell production, so let's say we're going to build another gigafactory, right? We see, a lot of challenges. First of all, you don't build a gigafactory overnight. You've got a lot of very intense, complex equipment because, we produce millions of cells a day, right? So you've got a lot of automation, a lot of advanced equipment, and then lithium-ion cells are actually very engineered products. A lot of people have had, misspent youth where they cut apart an alkaline cell somewhere in their garage or did something, and it doesn't look that complicated, right? It looks kind of, you could do that. A lithium-ion cell is a whole different animal. It looks very simple, but it's a deeply engineered product where, our electrodes, we hold tolerances in microns for that. And you have to build it just right. And it has to be, you have to have the cleanliness there. You have to have the materials control. You have to have the quality control to do it. Otherwise, you're going to have either a non-reliable product or an unsafe product. So you've got a lot of equipment development, long lead times for that equipment making. And then you've got a supply chain that you have to ramp. And, the supply chain really for lithium-ion cells was really designed for the consumer electronics market. That's where it was. Didn't come with a lot of extra capacity. And what capacity there was, we've taken a lot of it, right, to make EVs. So now we have to ramp that capacity. And, if you think about it, one of the big minerals that people talk about with lithium-ion cells, cobalt, for example, We're trying to phase it out, obviously, because of the various impacts that cobalt has societally and so forth. But it's still used often. How is that obtained? It's obtained in what people call artisanal mining, right?
Right.
Yeah, you don't drive a world change in infrastructure with artisanal mining, right? It's just like, if you thought about the current transportation sector, oil based, you certainly don't get it if you've got a few locations where you've got oil coming to the surface and you're grabbing that to power an infrastructure. You don't. So there's a whole shift that has to happen in the raw material supply chain to make these materials much more efficiently. And of course, those raw materials and the materials in general in lithium-ion cells, they are more than 50% of the BOM cost on a cell. So, we go after automation in a big way to reduce the costs, speed to reduce the costs. Our focus is on dollar per kilowatt hour, but one of the biggest levers, probably the biggest lever that we can pull is to reduce BOM cost. And that is all about the raw material supply chain.
Right. So when you're talking about cost and bringing that cost down in response to Dustin's point, then I hear cost in really two buckets, right? One is sort of this idea of, bringing down, sort of the incremental cost of an electric vehicle vis-a-vis an internal combustion engine vehicle, the cost of the battery. But you're also talking about major capital cost, right? So the cost of retooling the manufacturing and supply base. And so, before we get to infrastructure, I want to bring I want to bring Swati into that as well. But give us a little. Where are we getting these raw materials now, and what does the current battery supply chain work look like? Rather, are we doing this here in the United States currently, or is it happening elsewhere?
Yeah, unfortunately, we're not doing a lot of it in the United States. The vast amount of the battery supply chain comes from Asia. Different parts of Asia, some are from China, some from Korea, Japan, Malaysia, Taiwan. These are all, countries that are supplying raw materials for lithium-ion cells. That's really the big supply locations. Something that we're trying to do at Panasonic is really develop US and EU suppliers. This is important. It's cost effective too. Gigafactory where we have to ship everything in from Asia, that adds a transportation logistics cost. We'd rather have this raw materials coming from the US. But the reality is there's not a lot of that being done in the US, and we're working with various partners to try to grow that US supply chain. But even these, producing these raw materials, these are also very CapEx intensive businesses because they are entire manufacturing plants in their own right. So, you want to put in a cathode maker or a copper foil maker or aluminum foil maker, you're talking hundreds of millions of dollars, even for a very basic plant. So there's a lot of capital investment has to happen, and also a lot of time and know-how involved, because again, these are deeply engineered materials where the tolerances have to be amazingly tight to work.
So when we're thinking about the manufacturing process and the supply chain, we need to think about it broadly, from the development of the battery all the way through the production of the vehicle. And what you're saying is a lot of capital required. And if we want to do that here, it's going to require a lot of investment here in the United States, and maybe a more thoughtful process about how we encourage that. So we're into cost parity, to use a clunky term. I've also heard the term convenience parity used when we talk about EVs, the idea that, hey, I want to have the same ability to move from point A to point B in my electric vehicle that I do in my internal combustion engine, my gasoline powered car. And so Swati, how do you think about the convenience parity question? I mean, it seems to raise questions about infrastructure, for example, right? And the availability of infrastructure across the country.
No, absolutely right. I think, but I would like to challenge us to think about convenience, but from a consumer perspective. So it's not about trying to replicate a gas station experience, because unlike ICE vehicles, which are 99% fueled at gas stations, I think EVs are going to be fueled more at home and workplaces quite a bit. People will always start with a full tank of, so to speak, gas. So when we are thinking about infrastructure, we are thinking about, those workplace and home charging and making sure that that is very well done. And, it's our job to get electricity where the need is. So we are thinking from not only production to grid, but even beyond the meter to see what we can do to make it convenient in an ecosystem of offerings for our customers. But there is for sure need for public charging. And so that has to be thought through with geography as well as parity, as you talk about. And as utilities, we are in service for all. So it's not just about where it's commercially viable. So we as utility feel very strongly that even if there is a competitive marketplace in infrastructure investments in future, I think it is our role to make sure that we jumpstart this market with parity for all, affordability for all, and making sure everybody has equal access to electricity that are really necessary to, get electricity to our consumers, and so that they can drive and have a good experience. I think currently there may be range anxiety, but I think that all is going to be solved. My co-panelists talked about the battery technology advancement and creating more and more long duration. So if you think about home charging and long duration technology improvements, even in the car and the telematics and all the technologies that will be there to help consumer manage. So you also have to think about consumer behavior will also dictate where the infrastructure investments will come. So I think it's an exciting time to think differently about how we think about infrastructure investments and service for all, and also making sure even things like storm, during storm, there are places where there are evacuation routes. It's just competitive marketplace that will think about that, but as a utility, we think about how do we service those and make sure there is resiliency and reliability, even in a situation such as storm, and there is availability of power so that people can still move from a place of danger to place of safety. So when we think about infrastructure, we are really challenging ourselves to think big, think differently, and think it from a consumer viewpoint and customer viewpoint to really make sure that it's affordable and convenient. You talk about convenience. It's not convenient to go to a gas station. Just think about it. I would rather have gas come to me. So we are really thinking from those two angles as we are thinking about infrastructure.
Excellent. So Dustin, you live this. You drove across the country in an ID4. So how long did it take you? How many times did you charge? What was that like? I mean, to Swati's point, so there is infrastructure development. We have to think broadly and creatively. Give us some insights that you got about infrastructure from your drive.
Yeah, absolutely. And it's not my first rodeo. I've driven across the country.
Exactly.
In an electric car.
I'm pitching the ID4 right now.
I get it.
I know it's not your first drive.
Well, I think that's what's important. And my point to this is how much better it has gotten over the years. I remember the first time I drove an EV across the country was in 2010. And I had to literally stop at Keough campgrounds every 200 miles and charge for 4 hours. So the difference of that and move to today where we got to go wherever we wanted and didn't have to think much about charging. And I think that's the most important part, where you can go on a whim, on a bit of an adventure, and not have to worry that will I have a place to plug in. And that's really what we did. In terms of planning, we only planned where we're staying overnight. So we checked with all the hotels we were staying at if they had charging, and we used level 2 charging at those hotels. But in terms of on the road level 3 fast charging, which means the car will charge in about 30 minutes time, we didn't think about it a lot. We knew that those stations were along our route, and we really tried to take it to the limit. We took detours. We went through all of West Texas. We drove from Austin to El Paso, but we did that through going through Marfa, Texas, which is a cool town if anyone knows about that. What we wanted to prove is that without a heck of a lot of pre-planning, you could get across the country. And I think we're going to be doing more of this too. In fact, we thought it was so important that we included 3 years of included fast charging with the ID4. So for every ID4 that's sold, 2021 ID4, it comes with 3 years of free fast charging through the Electrify America network. And will all consumers use that all the time? It's hard to say, but what it does is it it takes away that objection, because we know that customers are particularly interested in, okay, how much does this car cost? You know, electric cars have historically been pretty pricey. How far does it go? Does it only go, you know, like some other EVs, a limited amount of range? And no, it gets 250 miles of EPA range. And the third thing is, okay, where do I charge? And we solve that too. So really the things that I've learned over the years of being around EV adoption, the three most important things to solve is getting to an affordable price, getting to a real world range, it's similar to a gas tank. And three, solving the charging equation for most people, at least enough to start the conversation. Because the conversation really needs to get, you're going to have the on the road charging. When you have it, it's free, but most of your charging is going to be done at home, and you're going to start every morning with a full tank. And I think as long as we can get the conversation started by really solving those three objections, I think that's really the secret of getting people to consider an EV.
Yeah. So Selena, why don't we get you back in here? Because I mean, you know, these two pieces, right? Cost, getting the cost down is, you know, battery's a big component of that. But also the amount of energy density, if that's the right word, in a battery, the ability to store more energy is also a challenge, right? Because those address two of Dustin's concerns. So where are we on that journey, and what do you see on the road ahead there?
So lithium-ion cells have been in production since about 1991, right? The first ones were Sony was making for camcorders, right? They were profoundly expensive compared to today. And, you know, the industry has been seeing, you know, the average has been something like 4% capacity increase per year, right? So these cells keep evolving, and they're continuously evolving. You know, there's been some shift in what's the optimum form factor. When we started with Tesla, it was an 18650. That was kind of the workhorse cell. Everyone made it. Works really well. Still works really well. You know, my Model S is powered by 18650 cells. Right?
I think they're right behind you. Isn't that 18650 right
No,
behind you there?
those are 2170s.
Oh, it's hard to tell. They're close.
Yeah.
They're close.
They're close, right? So, but this was a form factor change that was really done because it was more optimal for energy density. Now you can go to bigger cells. There's pluses and minuses to that. So a lot of folks are really interested in larger form factor cells. They like, you know, look at this and they go, well, there's less can per electrode and so forth. There is an optimal price point too that you consider, and an optimal speed of production that you consider. A cylindrical cell at a small form factor, you can make them really fast. And, you know, the cost of production and the really, you know, scrap rates that you encounter with this are relatively moderate. You go to a larger form factor cell, the construction becomes more difficult. It's more difficult to produce a low scrap rate. So, you know, there's pluses and minuses. We continuously study this, and so do our customers, right? So, you know, that one metric of dollar per kilowatt hour, you know, for right now, cylindrical cells are still the best deal in dollar per kilowatt hour. That doesn't mean that'll always be the case. It doesn't mean that 18650 or 2170 is the best bet here. You know, folks are experimenting with different form factors, but you know, there's that piece of it where you look at the chemistry, you look at the form factor, you look at the manufacturability, the speed of production, what you need in terms of equipment, scrap rates, and then also just economies of scale and efficiency. You know, a traditional consumer electronics cell maker would have had products for multiple customers running on different lines. They would change over lines periodically. This tended to increase the price of the cell. If you're going to make cells for EVs, the volumes are so big, you run one product 24/7, 365 days on a line. That kind of efficiency, no changeover times, really has an impact on the price. So there's a lot of pieces of this that one works on.
Mm-hmm. So let's go back sort of a little bit higher level now again, Swati, and talk about sort of the as you call it, the new fuel, right? Sort of the electricity that's going into these cars. How renewable will this electricity be in the future, and what are the goals that you have at Duke, and how does the utility, how does the power generation business think about renewability?
Yeah, so like you mentioned it rightfully, so it's not just the emission out of the tailpipe trying to reduce that carbon, but the fuel going in has to be clean. Most of the utility, if not all, have committed to net zero carbon production by 2050, and almost 50 to 70% by 2030. And those are just goals. But beyond that, as we work with the administration and some of the other technology partners that we have, we want to go faster than that. And we are not only preparing for generation being renewable, but I think it's very important to understand renewable generation is very different to manage on the grid. So we are trying to really modernize the grid and make it almost like a two-way flow, because you talk about some of the value and affordability, V2G, and once we have a max, there is vehicle to grid and grid to vehicle values that perhaps we as society can really use to bring the total cost of ownership of EV down. So we are thinking about all those investments and looking at a future state and say, how do we prepare now for that? For sure, we are shutting down coal plants, but one of the things that we have to make sure is how do you transition from a fossil fuel economy of where electricity generation was not but too long ago to non-fossil fuel, but keeping stability and reliability of the system appropriate to make sure that when you flip that switch or when you plug, it's there. So we are transitioning as fast as we can. I think this is where federal and state support, just like any other technology, it goes through a curve where federal and state incentive support is necessary. And we have that with solar, and solar prices have come down tremendously over the last 10 years. But if you talked to me about it in 2005, it was pretty high. So we are very hopeful that new technologies are coming, and these technologies are going to get more and more affordable. And we can transfer those cost savings to our consumer, bringing the total cost of ownership of EV down.
Yeah, I want to pick up on that theme of governmental policies that can be complementary to the innovation that's taking place. And maybe the best way to think about this is to start with the consumer, Dustin, and work our way back. So there is, frankly, new cars are, the average transaction price is somewhere around $38,000. A new car in general is expensive. EVs are expensive. Maybe even a little bit more than that right now. Is there a role for government policy to support consumer awareness and maybe address some of the early cost challenges?
Well, you've seen it helpful around the world, not just in the US, but the US has particularly good policies to help incentivize EV sales with a federal $7,500 federal tax credit. I will say that there's some confusion around that credit, though. Consumers don't always get it. Like, what is a tax credit? I mean, if you ask, I think the average consumer, they're like, I don't know. So I think that could work. We need to do a lot of education around the point of sale, even how to explain that to a consumer, but it's certainly helpful.
Can I just jump in there? If the credit were available at the point of sale, would it be more impactful? In other words, if it, instead of trying to understand whether I get a tax, return, I get a tax benefit at the end of the year. I mean, it would make more sense at the point of sale, I hear you say.
Yeah, I think so, because it takes away all that confusion. There's enough in the transition to an EV that somebody has to learn to also have to think about the price point and the tax credit and all these other things. It's a bit overwhelming, and we want to take away as much of that as possible. So if you had an instant credit, it's no different than anything else. The difference between something that's on sale versus something that has a mail-in rebate. A mail-in rebate, you're like, I'm not going to deal with that. Versus if it's just on sale and that's the price is better. So, and certainly those tax credits are bringing the price points of all of these cars into a much more palatable position. And what we look for is what you said, cost parity. And at our base price, we're at $39,995 base price for 94. Fantastic car at that price point. But then with the $7,500 credit, bring it down to $32,500. It's really within the sweet spot of the size of car that we have and comparable to other models that are on the market. The big ones like the Honda CR-V and the Toyota RAV4, the ones that are selling 1 million units a year. So with that, we think that's really important. And then also, the cost of ownership benefits for an EV are significant. So how much less the EV will cost to operate every year, and really getting that out there, and so that consumers understand it, is an important thing for us to be doing too, because not having to pay for fuel and the cost of electricity being so much less is significant to a consumer as they own their car. So there's a few hurdles that we have to get through, and those hurdles are just in education. Education and how tax credits work now, and hopefully that may change in the future to be a point of sale. And then really in those cost of ownership benefits that are out there for EVs, which are great.
Yeah, Selena, you mentioned a few minutes ago sort of the importance of developing supply chain and manufacturing capability. President Biden recently talked about a major infrastructure initiative that included some policies that support not only the consumer side that Dustin just talked about, but a transition on the manufacturing side, support for battery innovation in the United States, support for this manufacturing transformation is again, recognizing that you're capacity constrained and that the market's still small. How important would that be for some of the partners that you're working with, both on the OEM side as well as on the processing side?
Well, we're very excited about the Biden administration's approach on this. We think it's really important. I mean, it takes a while to ramp up a factory of any kind, right? And you're going to go break ground entirely and, produce one of the components in a cell, whether that's a separator, electrolyte, cathode material, anode material, one of the foils, cans. You're going to spend some years building that factory up, building up the know-how. For suppliers that we want to ramp, we'll spend quite a bit of time working with them to make sure that the material they're producing is actually the spec we need. And we have, these are, as I said, really engineered products. So the specs are really tight. They're really different than what would be, typically produced in many of these areas. So having that support from the government to, kind of smooth the way for a lot of this development is, I think, really important and really great.
Yeah. So, Swati, you mentioned, the charging, at home charging, at work charging, public charging. The president's infrastructure proposal also included, I think, 500,000 chargers in the United States. So is government support for public charging important? Is 500,000 enough? Do we know if it's enough yet? What is the role of government with regard to infrastructure development?
Yeah, so I think as I talked about it, I think connectivity for public charging surely is something that federal and state governments can really help. I think what would be important is whatever federal government does, there is some kind of alignment with the states. So that we can create connected highways. So you don't want one state to get behind and one state to move forward, because then suddenly you don't have the ecosystem that from a consumer perspective, they could. So I think focus on alignment of whatever we want to do on the federal side. There is connectivity on the state side, and utilities are playing their role. You may have heard about our announcement where we are partnering with our neighboring utilities to create a connected system of highways. Utilities do this. We are smart competitors, so to speak. We kind of hold hands and move forward. So I think we can play a good role. I think I do want to bring up a more important issue in my mind when it comes to interoperability, technical standards. Some of those things marketplace will work out, but federal and state government intervention to make sure that there are standards across, not just leaving it completely to the marketplace, will be very important so that you don't have interoperability issues as consumer drives from point A to point B. We do see that as a marketplace interoperability. I think technical and other issues we will work out amongst industry participant, but market interoperability, what I mean by that is only Tesla chargers can charge Tesla only car. Rivian just announced that they are going to create their own network. That just, you can imagine how inefficient that could be if everybody does that. And it'll increase cost of ownership for our EVs. And you have to gravitate towards one another. It would be really good if federal governments and others think about that symbiotic ecosystem of marketplace, that if they can kind of think about that, not oppressing competition, but thinking about standardization that will enable customer experience to be much better than perhaps it could be if left it completely to the marketplace.
Dustin, do you want to jump in on that?
Yeah, I agree. I would say that, Tesla's kind of an outlier there, but they were the first to market, right? So they have a bit of a first mover advantage there, and that's why you see them with their connector type. Every other manufacturer pretty much has adopted the combined charging system connector, the CCS connector for fast charging. But as I look at charging, it's it's a tough one to solve, because the other thing that you don't want to do is you don't want to limit this car or these cars just to people that have a garage. Then you're getting into socioeconomic issues as well. You don't want to limit these vehicles to a certain class of folks that can afford a house and they can have a garage. That's why I think, this is going to take a lot of thought. And DC fast charging is not the only thing you want either, because that certainly is going to help for someone that's taking a long trip. But you necessarily don't want to be charging the battery, and Selena could tell you this, with DC 480 volts every single day. Not that somebody maybe would, but it can hurt the longevity of the pack. So we got a lot of problems to solve when it comes to charging. And in terms of adoption and thinking about the long-term adoption of EVs, this is kind of what I opened the conversation with. This is going to be one of those challenges, because people that are living in multi-unit dwellings, people that can't afford to put in a charging station at home, need to make sure that their workplace and other places have charging and they're appropriately distributed. And if you think about the parking lots across the US right now with how many cars that are in them, that's a big undertaking. So we'll see how that goes, but that will need to be really the next thing that we solve, and it's going to have to be really carefully thought through, because it's not just, you've kind of seen how electric vehicle charging has been taken care of up till now, and I wouldn't say that it's been fantastic. You've got a charging station at a Whole Foods or somewhere doesn't necessarily help somebody, right? It's like, where are they going to be keeping their car for a long period of time? How much is that going to cost? How are you going to share that? It's a difficult problem. So that'll be one that's going to kind of work out over the next 5-10 years, which I think will be an interesting space to watch.
But it could.
I don't have the answer necessarily.
Right, but what you're saying is it could be a limiting factor, or it could be an accelerant, or depending on how we work through that. Selena, do you want to offer anything in this space?
Yeah, we know that charging is something that's an issue, and you don't want it to be just people who own a garage, right? It's very possible on a 110 outlet. I charged our Model S on a 110 for a long time, which seems very, very slow, but it worked. At the same time, if you look at, okay, let's put charging infrastructure out into every grocery store, or parking garages for movie theaters and stuff, and make it really easy. Or you have it out at SeaWorld or Disneyland or something, right, where you can charge up your EV. Super cool. There's definitely a utility infrastructure piece of this. There's kind of a limit of how much copper you're going to pull out to a parking garage, or how much you can pull right now. So there's definitely a lot of planning that has to go into that. We looked at this when I was at Uber. One of the big discussions was that rideshare and taxi fleets, a lot of cities were saying, okay, we want them all electric by some some period of time that was not in the distant future, and trying to figure out how to do that and how you would support an infrastructure for that kind of fleet in a city. There are definitely some real challenges, and it's one of those things that those are the kind of challenges that governments tackle very well and think through very well.
Really, really great point. I want to come back to sort of, while we're on the subject of government, this question of, well, why should the government be doing these things? We've kind of answered that question in a number of different ways, and clearly one of the things Dustin raised earlier, for example, was the notion of sustainability, and certainly Swati and Selena, you both mentioned that as well. But there's a competitive imperative also, isn't there? And help me understand that a little bit. I mean, let me start with you, Selena. You mentioned that a lot of the raw materials and maybe components to battery manufacture are coming from Asia. Do we risk, is there a global competition, and do we risk losing it if we don't get control of supply chains and manufacturing and minerals?
Yeah, I think so for a lot of reasons. I mean, in the United States, we've got kind of one conversation going on about electric vehicles and electrification, but the rest of the world has a very different conversation going on. You've got a lot of the rest of the world saying, we're going to limit internal combustion engines. We're going to create all kinds of incentives against internal combustion engines. We're going to, not allow internal combustion engines and taxi fleets in our cities, at some period of time, 2020 or 2030 or something like that, right? So if U.S. automakers want to be selling not just in the United States, but around the world, which is really important, that means that we have to be very competitive in the United States in manufacturing electric vehicles. And if you're going to be competitive in that area, you have to have some control of your supply chain, right? And it's a heck of a lot easier to do if you've got a domestic supply chain. And you also see this in Europe, where the European regulators are also saying, hey, we're going to tariff the heck out of raw materials coming from Asia and other places. We want our manufacturing base to develop supply chain here. They're doing that for a very key reason, that they want to be competitive. They don't want their automotive industry growth to be throttled by other parts of the world. And that's the danger we're in if in the United States we don't develop this.
Yeah, it reminds me a little bit of one of the near-term challenges the auto industry is facing with the availability of auto-grade chips, for example. It's almost to some degree like a cautionary tale. Could we be facing similar constraints with regard to the critical components that make up electric vehicles? This innovation that we're trying to develop here, and will we have similar challenges? I mean, Dustin, do you want to add anything to this question of competitiveness?
I think it was stated very well. I completely agree. I mean, I think in terms of even a shift from 2% to 5% to 10% of the market, the numbers are mind-boggling, right? So, and that's only in the short term. So when we get to 20%, 50%, 70% of the market turning to EVs, this supply chain is going to be vital, and nobody knows it better than Selena. So I think it was well stated, and it continues to be the thing I think that will keep us up at night, of getting these things ready, So, and I agree that these things have to also, the supply chains have to be localized in each market. A global brand like VW, we have over 150 factories industrialized across the world to build cars. And we have, I think, about 8 industrialized to do electric vehicles now. And those will be growing. But to really supply those, you need to have local supply chains. So, yeah, I completely agree.
Swati, do you want to add anything to this competitiveness question?
No, I think you have similar thing. You think about every component. So when you think about the infrastructure, charging stations, and so on and so forth, I mean, I won't belabor the point, but that all has to be thought through, because we can sit here and say we want to put so many infrastructure charging stations, but do we have components? And the point that my co-panelists are making, I think having some control of supply chain within the country is really, really important to really accelerate, because the last thing you want to have is you have consumers now adopting, but now the ecosystem is not ready to support the consumer, because that'll really decelerate adoption, because consumers will find it inconvenient to wait for a charging station. So I bought a car, but now I can't get a charger. So that kind of stuff we'll really have to, when we look at supply chain, John, I'm thinking anywhere from the metal to make the car all the way to electricity in the vehicles to where the consumer are driving. We have to look at supply chain ecosystem across everything.
Yeah, great point. We could talk about this all day, and I feel like we're just getting started, but we're almost out of time. I want to ask you each one last question, and it's a question I get often, and the question is this: when are we going to be at the point at which everything is an electric vehicle? And, I'm going to guess the answer is not tomorrow. So I'm going to add another question to it, which is what is the most important thing that we could be doing? And the we could be government, it could be industry, it could be societal. So again, I'm going to start with you, Dustin. When do we get to all electric? And what can we do to accelerate that journey?
Well, I think it's going to be a lot faster than anyone thinks. I think there's going to be a few things that actually accelerate that. I think if other technologies such as autonomy and those things will help as well. When companies can start delivering vehicles to consumers without having any kind of real estate needed, like literally the cars can leave the factory, drive directly to the customer's home. Think about those things, right? So that really starts to help speed up those things, and that's stuff that no one's even really thought of before. So that's not near term, I would say, but that's out in the future. And I would think also what I focus on all the time is just engaging really closely with consumers, get them behind the wheel of EVs and get them to get it. Because I think I've told you this before, the first time you use an EV is, and I'm old enough to remember like personal computers coming into my house and then using a cell phone, is that aha moment to say, okay, well, this is just plainly better. And I get it. So the more that we can get consumer adoption and consumers in the cars, driving them, it's like a light bulb going off. So I think that's the first step. The second step is to be able to scale and get a lot of vehicles out on the road. And the third step is further technologies that make it slippery. Because what we see is, especially around technology, when we can drive down cost and make it easy to start to get to a consumer, it starts to grow a lot faster. So I think that's kind of the three phases of adoption. In terms of timing, I think that we're going to be a really interesting time between now and 2025 and 2025 to 2030. The next 10 years are going to be really telling about how quickly this goes, but I think it's going to be faster than most people think.
Selena.
Yeah, I don't, going 100% electric, probably going to take a while, but up to 80% is going to be, I think, as Dustin is suggesting, a lot faster than most people think. Because once you drive an electric, you're like, oh, wow, this is a whole different world. And also once you're engineering electric, it also opens up all kinds of different opportunities in engineering the car, which, is going to get really interesting. The autonomy piece, it's a lot easier to do if you've got a big battery that provides electric power to the computer that's running, the algorithms that you're using for autonomous driving. So there's a lot of opportunities there for, real jumps in technology that I think everyone's going to want to do. There's also a lot of opportunities to electrify a lot of different market segments. People are looking not just at cars, but of course semi-trucks, but also, ships, right? And marine applications, which is, it doesn't strike us that intense because it's not a consumer demand, but it's actually kind of important. And, I think you're going to see a lot of adoption there. And, with that, you're going to see a lot of adoption of solar power because people, they like the fact that, you can charge your car from your house, from the solar panel, and it's really cost effective. So I think we're going to see a lot of that. I think the thing that needs to happen is we need to embrace the change. This is happening. It's an exciting new world. Let's go for it. That's, you got to invest, you got to go for it.
Swati, last word goes to you.
Yeah, I am actually, call me optimist, but I feel like I think it's going to happen sooner versus later. I mean, if you ask any EV owner, they don't want to drive any other car. And, I've been driving EV for at least 6 to 7 years. And so I don't want to drive anything else. So from an experience perspective, I think EV is good. I think it's super exciting to see how the industries are coming together to play their role in the whole. And there is a tandem progress. So you have Alliance for Transportation Electrification at the state level. You have Zeta that Joe Breton has started at the federal level, where many industry groups are coming together to say, hey, what can I do? And I think that's going to really work very well to progress. And then there are even states like California who have put a moratorium and said, hey, after 2045, I just won't have ICE vehicles. So I think all of these things are going to anything but accelerate EV adoption. And I think it's a good thing. I think we have to make sure that it is for all. And I think if we do that well, it will be for all. That's super important to us.
Great. Well, I want to thank Selena, Swati, and Dustin for a really excellent discussion. Very lively, very informative. Thank you all very much. Appreciate it. To conclude today's discussion, I'm pleased to have Scott Keogh, the CEO and President of Volkswagen Group of America, who will provide us with some closing remarks. Scott oversees all of the company's brands and operations in the US, as well as their manufacturing operations in North America. As Auto Innovators, the United Auto Workers, and the Motor and Equipment Manufacturers Association recently noted in a letter to President Biden and congressional leaders, we believe that policymakers and private sector stakeholders must work together to develop a comprehensive national vision and strategy for vehicle electrification. Auto Innovators will continue advancing the conversations on this crucial subject. And as always, we welcome your participation and feedback. To learn more, go to autosinnovate.org/EV agenda. Now over to Scott Keogh, CEO and President of Volkswagen Group of America.
Before everyone goes their separate ways, I want to take this chance to point out that in a very important sense, we're actually not going separate ways. As an industry, our future is electric. Full stop. That's the road we're all headed down. And although smart public policy decisions can be a tailwind that speeds our collective progress, we also know that American drivers are the ones that will lead this progress with their hearts, their heads, and with their hard-earned dollars. Drivers love what electric represents. It's the future of mobility and a more sustainable future at that. Our job is to make it possible for everyone to participate in this future on their terms. Because if Americans are going to go electric, they want it all. Great range, great price, a fantastic driving experience. Ultimately, Americans want sustainability without sacrifice. To ensure everyone can get the driving experience they're looking for, there can be no one-size-fits-all. We expect to see a lot of different models from a lot of different automakers. We expect there to be many winners. But to be one of them, aspiration is not enough. This moment calls for serious commitment and, of course, serious investment. By serious commitment, I mean working to meet the demand for sustainable mobility, no matter which way the political winds happen to be blowing. The White House might change hands 4 or 8 years from now, but our strategy should not change. We talk a lot in this business in normal times from a stage about revolutions. We talk about moments and products that change the game. The truth is, that's not usually how it works. Real change is slow. Then all of a sudden, it's not. Progress builds gradually and quietly, and then in a moment it tips. Volkswagen is committed to being one of the companies that makes it tip. Not just because electric is a powerful way to reduce emissions, not just because it's one of the world's most exciting new technologies, but because increasingly it's what drivers want, and that merits serious investment. The Alliance has calculated that our industry plans to invest $250 billion in electric vehicles by 2023. Volkswagen is responsible for a significant portion. Take an example. A few years ago, we initiated an $800 million investment to build American-made EVs at our facility in Chattanooga, Tennessee. There, we also established an engineering center with a special high-voltage lab. We're testing and optimizing electric vehicle cells and battery packs for our EVs of the future. These vehicles start rolling off the line in Chattanooga next year, and the first of many long-range Volkswagen EVs to come, the ID.4, is at US dealerships now, and driveways, including my own. John has said, and rightfully so, that the long-term future of the auto industry is electric. And at Volkswagen, we're just as excited about what that means for the industry in the near term. There's an enormous opportunity right in front of us. It's clear what's required of companies that want to take advantage of it: commitment and investment. As an industry, we have a good start to both, and it's just the start of all that's to come. With that, thanks for having me. It's great to be with you all today, and I look forward to working right alongside you on this fantastic and pretty cool journey ahead. Thank you very much.
Thank you for joining us today. Watch for announcements on other sessions as we continue to chart the path to a cleaner, safer, and smarter transportation future.